Hello, everyone. Hi, good evening, good afternoon, good morning, depending on where you are. My name is Chris. I'm from Token Engineering Labs, and today we are together with BlockScience Labs doing a presentation of the walkthrough of the token engineering process and best practices, where we have invited the CEO of BlockScience Lab, Christopher Frazier, who will take care of the second part of the presentation and explain their services and their best practices with respect to implementation and data and analytics in crypto economics. And I heard from Chris that he has also two demonstrations of two products that he wants to share with us later today. So the agenda for today is we will have Julia Redgard from our team explaining the token engineering process on a high level in general, focusing on the discovery phase, design phase, and deployment phase. I will take over and give a little bit more detail about the specification in token engineering. So what is the translation between the discovery of the token engineering system to the specification of the mathematical model? And then afterwards, I will hand over to Chris, who will explain how BlockScience Labs is approaching this implementation of the model, running the experiments, and preparing all of the information with respect to data visualizations and data analytics. So this is it for today. I'm handing over to Julia now, who will start. And feel free to ask questions in the chat if you have them. We are happy to address them either after each section or where they fit or at the end of the talk.
Cool. Thank you, Chris, for the introduction. So we'll start kind of general. And so we want to answer what is token engineering. And it is a subdiscipline to complex system engineering. And it is focused to develop tokenized economic systems that is based on blockchain technology. And we are doing so by drawing on a range of different scientific disciplines as mathematics, engineering, economics, data science. So there are a lot of things to draw from. And we develop these systems by leveraging methods and different techniques from these disciplines. And we want to therefore use the token engineering process as it contains all of them. And the token engineering process has some different phases. So we want to start with discovering the system, which is more about ideation and understanding the purpose and the goals and the mechanisms and subcomponents of the system. And then you move to more formal specifications and so that you're able to run some experiments. And we like this process, and it's a great position to be in as a project, as you're able to make decisions that are based on quantitative analysis rather than making assumptions that is from your own beliefs, basically. And here is a more concrete picture of the token engineering process. So we start with the discovery phase, and here we would like to look at the system goals and requirements. And we also look at the components of the system and associated mechanisms, parameters, and metrics. And we also want to look at the political economy. So what governance structures are there? And do you want to use any different instruments from monetary policy, fiscal policy, and anything like this to steer and control the different aspects or conditions of the economy? And then once you have been here, you will move on to the design phase, where you will move to make the mathematical specification of the model or the design object and make the formal specification of the state space, economic mechanisms, metrics, and policies. And then finally, when you have this described, you can also move it over to a computer computational environment. And then you may formulate and execute some experiments that can then be used to make choices about mechanisms, parameters, and governance policies. And then, so one of the main goals in the beginning is to define the goals and business and technical requirements. and also to determine the different constraints and invariant properties and conservations of the system, and also defining and analyzing the different system components. And in this sense, the token engineering process helps to build resilient ecosystems, just because we are able to run these experiments and simulations. And this is a quite general overview of a design process and what you would need to actually design anything. But in our case, this would be the design object, that is our token economy, or maybe even our token. And we have an agent that wants to create this specification of the design object. So this would be us, or the token engineer. And in order to fully understand the design object, we need to understand what constraints it's subject to. So this could be any constraints. It could be like physical constraints, or it could be due to infrastructure or other constraints that you decide to define yourself. It can be requirements that you want to satisfy because you've realized that the system needs it to be in a certain way. It's also composed of different primitives or building blocks that you would use to create the token economy, and it is situated in a particular environment, and it is always intended to accomplish a particular goal. So it's great that we have this design object and we understand all of these things around it. And once we are able to articulate or specify, it's a really good thing, because then we can move on to subsequent phases. Yes, so I will begin with the discovery phase and what to expect when going through a discovery phase. Typically, we would start with the market research, and here we would look at the competitive environment or on other projects. What are they doing well? What are their challenges? What is, in general, everything looking like, so that we may create the best possible system, of course. And we would also look typically on the documents of the project that we are working with. So maybe they already have some requirements defined, or maybe they already know some of the system components. And then we would move on to definition of the system goals and requirements. And yeah, here it's good to already know or have a sense of direction. It helps also to clearly define the goals and maybe even formulate them in terms of metrics, so that you can at a later point determine the success or the performance of the system. And requirements are also super important, because it defines sort of the design space and how we want the economy to look like. And it is, really closely describing what it is that we want to mathematically specify at a later point. And then it's also, as with any business or anything else, we want to define our stakeholders and also their roles and their associated motives, interests, and eligible actions. I will go a little bit more into this later, so I will move on to the next one, but this is an important part. And then we will also, based on these analysis of stakeholders and the participants, we will be able to determine where value is created, where value is extracted, and where it is transferred. And this will in turn help us to look closer at the incentive structures and trying to define an economy where value is cherished and incentivized. And yeah, and a big part is, of course, to define the subsystems and their mechanisms, parameters, and policies, which is the major building blocks of the economy. So trying to define these as closely as possible is a big part of it. And often we try to use different type of visuals to do so. We might have some system maps, or we might do some stock and flow diagrams, where the stock and flow diagrams are really specific in trying to determine the stocks and the flows, and so the states of the economy and how different actions and mechanisms make assets move along the system. And yeah, and then you want to also, again, define the political system. So you want to control the economy, and therefore you have to impose different policies, whether they are monetary and you want to change the supply of a token to increase or decrease spending or anything like this, or if you want to use fiscal policy to impose some taxes to redistribute wealth. And then finally, based on all of these things, you would want to choose a token model and token design that is appropriate to all of the things that you have now formulated and described. And then I would like to once again go a little bit deeper. I've decided to, because we are not having all the time in the world, I chose a few parts of the discovery phase that we can talk more about. So one of the key parts is understanding the stakeholders and roles. And here we like to make the distinction between stakeholders and roles, where stakeholders usually are associated with their interests, strategies, valuable capabilities, and valuable assets. And as you can see here, we have all of the stakeholders here, but each stakeholder can take on different roles. So it doesn't mean that just because you're one stakeholder, you cannot take another role, but you can take several roles. So that's why we also want to identify the roles that are instead associated with their eligible actions. And this is important because the eligible actions are the ones that are associated to the mechanisms and dictates what can actually happen in the system. And that's why we want to design the system in such a way that the roles that are available, or the roles that can be occupied, will not be able to do things that will deteriorate or destroy the system in any kind of way. So we try to be very, very clear on what can be done so that the system remains resilient. And then we also can do something in even quite an early stage. We can explore causalities, which is cause-effect relationships. And you can explore different research question or define any research question that you like to try to understand the cause-effect relationships between different metrics, variables, controls, to see what happens. For example, if you want to impose a tax, what happens when you raise the tax? What happens when you lower the tax? And this is giving you a good understanding of your economy and what might happen, but you still have to be careful because as it is in a quite early stage, you are making qualitative assumptions about something that will happen. And so you cannot for sure know that it's true until you are able to formally describe the economy and also make simulation and experiments that is based on data. But it's still a good thing to understand what's going on and what you want and how this might happen. And then we have the stock and flows, which I briefly mentioned earlier. And this basically says that you have some stocks and you have some flows. You also have some sources and sinks that are mentioned here. So maybe you will have some places where assets come from. You have a few stocks here and you have inflows and outflows of these stocks. So this is a really good way of visualizing the system, because later when you move on to specification of the system, you want to define exactly this. So what happens when I take an action? What happens when I trade something? What asset flows where, and what changes in the states will happen? So that's one of the reasons we want to do this, and it's very good at bridging the gap between the formal specification of the system. Yes, and so now we're back to this diagram again, and I just want to say that once you have all of these things formulated that I've just mentioned, then you would want to reach this state where you are able to specify the design object. And I would like to give Chris the word now, because he will tell you more about specification and how to best do it.
Thank you very much, Julia. Thank you for the comprehensive introduction to the token engineering process and highlighting some of the most important features that happen along the way of gathering the requirements for our economy that we're about to design. I will share my screen now. Please give me 1 second to do this because I don't want to share the wrong window, obviously. And then I will continue with what you've started to present. So where do I have it? It's here. Cool. Okay. So So this is the economy, and then we move over to the slide that you've shown. Okay. Now I don't want to share it. I want to slideshow. So this is what we want to do. Okay. So let's move over to the next stage of the token engineering process. So once we've accomplished the gathering of all requirements, coming in informal or more formal conversation with the client, where they would articulate what are the design constraints that allow us to design the economy, then we can move over to formulate mathematically what we want to build. So the requirements coming from the discovery phase, and we can use all of the tools that Julia described before. So we can build diagrams, we can build tables, we can even conduct interviews with people to make sure that we understand what are our constraints on the business side, what are our constraints on the technical side, what are our constraints on the legal side, and even to some extent incorporate some strategical thinking or strategical assumptions how we should set up the economy so that the project is successful. But the main idea here is to limit the design space for our mechanism design. And in some of the previous conversations we had here at the Token Engineering Labs community, we've mentioned that what we are doing is we are defining the economy or the mechanisms of the economy on a microscopic level. So we are looking very much at the level of what an agent can do. What would be the system's response? What would be this one particular mechanism? How would this one particular state update look like? Before we then concern ourselves with the emergent properties of this economy. Because in the end, this is on the macroscopic level, what we want to optimize for, what we want to design. But our mechanism design, mechanism definition on the micro level is restricted by all of the constraints that we've articulated in the discovery phase. So the goal now is to formulate those requirements, translate them into mathematical language, and then move over to defining each of the mechanisms individually. So how does this look like? And we talked about this in several meetups and several events already, but this would be a specification of a system. This is what we need to be able to formulate how our economy looks like. And the most important thing is the state of the economy. So we start with the definition X out of X, where we would say that these are all of the stocks, those are all of the variables that we have in our economy that we need to count, that we need to take care of, that we need to understand, so that we know how those states would be affected by system events or by agent actions. So what are actions now? Actions are selections of mechanisms, selections of state transitions that are triggered by an agent or by a system so that they have an eligible set of actions at each point in time. We say, given the system is looking like this right now, you as an agent or you as a subsystem or you as an entity or you as an environment, even we can model this as well, are eligible to take this one particular action now because we allow you to do this. And this is also in the design space of our economic design. We can say which actions are eligible when. So we can restrict this and we can allow people not to take particular actions at particular points in time. Sometimes in token economies, this is represented via shares or via token, where you say, if someone doesn't own this, he cannot do this, right? So like actions can be, permitted by some state condition. And then if we have defined all of those actions and all of those states of our economy, of all of our subsystems and our components that we're looking at, then we can put them together and define a mechanism. So a mechanism then in this context is a combination of an action and a state. So we say that given the system is in this state and given an agent or the system performs this one particular action, right? So this is what we have encoded here in the arguments of the function f. Then we can say that the next state, so x prime of the system, is supposed to be this. So we can prescribe what the state update will be if this one particular action is taken at this one particular moment in time. And this is quite beautiful because this allows us to conduct mechanism design. We can say, hey, let's look deeper into this X. Which states are there? Like, because this is not a point. This is a vector. Those are many states that are describing the current situation in the system. And we can look at each of them individually and we can say, okay, we want this state to be mutated like this, or we want to have this functional form that is describing the evolution of the state, and so on and so on. So here, this opens the door for a lot of mechanism design that we can conduct on each of the state updates for each of the actions that agents are taking. And all together, combining this, we call this a state transition, right? When we say that there is this state, there is this mechanism that we have, and we have an address or an agent in the system doing something. So this allows us to talk about those things as state transitions in our economy. And for several reasons that we've mentioned in some of our previous conversations here around Token Engineering Labs, we said that this is very beautiful to define those state transitions on the blockchain infrastructure, because we have this state space and we have full understanding about the state space. And we are able to design very rigorous and very robust mechanisms based on the information that we have. So how does this then look like? So for each point in time, we then can say we have this situation at the system today, and then there is the state transition, and then we have the situation of the system tomorrow, and then we have the state transition. So this is how the system moves. So this is one possible trajectory of the system, and this can be any crypto economy that you're looking at. It can be a DeFi protocol, it can be an AMM, it can be a token economy, it can be a marketplace, it can be basically anything that you can represent with this framework, which is almost everything. And what we have described here below is one particular very important argument that we are imposing onto those state transitions. So what we are saying here at this point in time is we are saying that there is a value function that we restrict to have a constant value across all of the state transitions, which means that there is something that we keep invariant. There is something that doesn't change. So we are choosing all of our state transitions, we're choosing all of our mechanisms in such a fashion that we restrict the possible evolution of this function to nothing. So like it's constant. Which is beautiful because it reduces the possibilities that we have in our design mechanism design composition, but it also allows us to uphold the system requirements. So for example, and now this is where the design space and design phase connects with the discovery phase. Now, once we have articulated one particular design constraint in the discovery phase, for example, the number of tokens in the economy has to remain constant forever, right? So this could be one of the design constraints. There is an economic conservation that you impose. So whatever someone transfers to an account, this other account has to receive. So there is no loss in balance throughout all of the mechanisms. This could be one example of conservation. But once you have articulated those constraints on how you want to design your economy, then you can make sure that you're only allowing eligible mechanisms to your state transitions, so that those properties are upheld. And this is what we mean by designing robust token economies, where we can choose to only allow mechanisms that particular system conditions are always met. And this is important for projects who want to satisfy specific business or technical or legal requirements. So what does this allow us to do? I don't want to go too deep into this, but this allows us to map the particular state updates into the configuration space. So we can say that this would be a regular state transition where we say, okay, this is like the starting point and this is the end point of our mechanism. But what we can say is that you're starting here and you have to land with your mechanism in this subspace of the state space, which we call the configuration space. And all of the points in this configuration space, they fulfill this one condition. Okay, so this allows you to build purpose-driven mechanisms. We talked about this already. Okay, so how does this specification look like? I want to give you a very formal introduction now. The formal introduction is we are defining a discrete event game on top of the blockchain infrastructure. Again, this is why the state space is so useful. So what we are saying is we are just describing all agent and system level states. So depending on the number of agents and depending on the system, the dimensionality of the system, we are just describing it here in those spaces. And then we are just adding them up and saying, okay, our system state is just the multiplication of those. So we are adding them up and saying we have to understand all the local states of the agents, and we have to understand all the global states of the system to make sure that we have a full understanding about our token economy. The next component we need to define is the decision mapping. So like, what are the eligible actions? What are the choices that agents can do, and at which point in time can they do this? So you see, again, a state dependent and an agent dependent mapping of the eligible sets, of the eligible action sets, which allows you to say, at this, in those conditions, this is an action that we allow an agent to do. We are not saying whether this agent will do this. This is a different question. This is going into behavioral modeling. We will talk about this at a later stage. But right now, we are saying what are the actions that can be taken at a particular point in time. And once we have defined this, then we can define the state transition function, which is basically giving you this x prime or this xt plus 1 based on the input of the state and the action that is taken by the agent. How does this look like in a particular example? This is one specification of one particular mechanism where you say there is this burn to withdraw mechanism where you would have those particular state updates defined. So you would see that this capital S is being updated like this capital R is being updated like this, P like this, and F like this. And then, this is what I meant before, you can very explicitly look into each of those lines and say, I like this mechanism, I don't like this mechanism, I like the implications, I like the functional form, but I don't understand the parameters. So let's understand, let's make sure that we really test this mechanism and understand this ramification of our design. And once this is accomplished, then you can move over to implementation of this model into a computational environment. So once the system is specified mathematically and formally, then you move over from the design phase into the deployment phase, where the goal is to build and implement the model of the system that is precisely following the state updates mentioned before, so that you can test your mechanism, so that you can run your simulation experiments, so that you can compare the consequences of your mechanism and parameter choices. And this is precisely why we have invited BlockScience Labs today, and Chris Frazier will present how their approach is on the implementation and testing of such computational models. Chris, can I hand over to you?
Oh, perfect. Thank you. Yes, so I'm Chris Frazier. I am the CEO of BlockScience Labs. Thank you very much for having me here. And I see some familiar faces and people in the audience, so it's great to see you again. So can I please take over sharing, and I'll share mine instead?
Sure, please.
And make sure I do this correctly. So we want a window. And then slideshow. Okay, so are you able to now see my version? Perfect.
Yeah, perfect. Thank you.
All right, so what I'm going to do is go through the 3 areas that we've been focused on: our platform, the presentation layer, and then other services we offer, and how that all relates to what Julia and Chris just presented to us. But first, I want to address the question I get all the time. So I know of BlockScience. What's the difference between BlockScience and BlockScience Labs? Well, to put it simply, BlockScience is a research firm that actually incubated BlockScience Labs, and we worked together to figure out how we could create a separate product company that would try to create scalable solutions that follow the principles that are implemented and designed by BlockScience. So we are very closely partnered with BlockScience, and I'm going to touch on that a little bit again later. But we are 2 completely separate entities. Our mission at BlockScience Labs is to create solutions that are holistic, inclusive, empowering, integrated. And what I mean by that is, first, holistic is that we really want to focus on the entire process. There are some that will just jump straight into trying to answer questions by seeing what data they have and then playing around with the data and then doing some modeling. We really think that it's very important to start with everything that was just reviewed earlier in this presentation. You really have to start with forming that problem statement. You have to go through the design because you want to make sure you're answering the right questions, which is a real challenge in data science work. A lot of times in the business world, you'll have executives complain that they just feel like they're not getting the right answers from their team. And that's because there may not be enough of that information sharing and spending of really making sure you're addressing the right problems. So we build solutions that are holistic. Inclusive is, we think that generally these projects are done by teams of people, and those teams of people include others that are not technical. You have project managers, you have people in products, you have executives, you have stakeholders, and everybody needs to have access to the same artifacts to get a deep understanding at on demand when they need it. So we are building a platform that's inclusive to everybody that's involved in these projects. Empowering, we think that the people who have the skills should have the ability to do the work that they need to do to share their knowledge with others. We're not trying to upgrade the skills with tools and automations for things that people aren't specialized in. If you have a data engineer or a data scientist on your team, we want to make sure they have access to the things in our platform that lets them shine and get their work done and share those insights with everybody else that's on the team. And then finally, integrated, which kind of plays into the next slide here. So our goal is to really create a platform that integrates with a lot of great open source products, has integrations with other closed source products, other tooling with APIs, and really creates an environment where you can choose the way that you want to get the work done. Kind of like a tool shed, where we are housing a bunch of different options for you, but really you get to choose exactly what tools you want. We're not trying to be like the Swiss Army knife, where if you use our platform, then we say you have to use products A, B, C, and D, and that's the only way to do things. That's just not the way that we envision this work needing to be done. And we really want it to be easy to choose the right way to do things while still having the connectivity of what the platform offers. So what the platform does offer is we have universal access. So it's very easy to invite other people to projects, and everybody can be collaborative in getting the work done and are able to find the different artifacts that are within the project. And I'll be going through a quick demo to show you what I'm talking about there. For hassle-free setup, this is key for if you're working with others on different local environments. This allows you to create a shared collaborative environment in the cloud that doesn't run into problems such as I write some Python code, it's able to work on my machine, and then I have you go and try it, and then you just keep getting error after error because you don't have the right packages, and you gotta troubleshoot through each of those before you can even do a simple task like using that code. What our platform allows is so that you don't have to worry about that. If I get it to work on the platform, then anybody else who's in the project can easily run any of the code and doesn't have to worry about any sort of like environment issues. The platform really promotes transparency. It's very important to allow others to be able to reproduce your work, all part of testing, and for anybody to be able to, like I said, on demand, be able to come in and find the information that they need for them to be able to make their decisions. And then also there's an external element of data storytelling. So if you have your project that you want to share with others, our platform allows you to publish those findings so that others are able to read your documentation, see how your model works, and maybe even fork your model or clone your model and be able to do some work on their own. So why don't we just dive right in, and I'll give you a view of what the platform looks like if you have not seen it yet. So when you first log into the platform, it takes you to your project screen. And so projects are collaborative containers of work, and you can use them for anything you really want to do. If you're doing consulting work, you could be a project per client. If it's internal projects, you could have it per team. It could be different projects that come up throughout the year for the team. It could even be used for students, different research projects that you're doing. And you can invite colleagues or your professor to be able to go in and see the work. And all these are connected to a GitHub account. So if I was to create a new one, I would click on new project, and it's going to bring up all the different GitHub repos that I have access to. And it's as simple as just selecting any of these. You can give it a name and give it a description. I'm just going to cancel this because I have a lot of projects on mine. And that'll bring up a brand new project that'll be already populated with all the artifacts that are within that GitHub repo. So if I was to go into a particular project here, you'll see that there's several tabs, and you'll have some header information that you can go ahead and collapse. But this just gives you some information so you know the metadata of the project. But within here, the first thing you're going to see is the files. So this is giving you a view of all the different artifacts that are within that repo. If it has folders, you can dive in a little bit deeper to see what's in those. But this is more of a read-only view of what's located there. So if you wanted to, if you wanted to see if somebody did some updates or if that file was located there, this is an easy way to see that without having to jump into the repo and find the file. Simulations, this is something where if you have a CAD, it's specific for CAD models, but we have created an instance on AWS where you could run your really large computationally intensive CAD models on our AWS server if you desire. But this is not the only way that you can actually run code on our platform. This is just very specific to really large CAD models. And what's nice about this is that if you do run a large CAD model, this is available to everybody else that's within the project, as well as the data. So if I was to download these results, I have access to them. I could put them into my local machine. I could connect to these data results within the JupyterLab integration, which I'll go into in a minute. But also anybody else in the project can do the same thing. So it creates that one source of the data that was produced so that someone else doesn't have to then take your code and run it themselves to reproduce the data. It's already there and stored, and everybody has access to it. Our JupyterLab integration. So we decided to integrate with JupyterLab so that we had an IDE in the platform. And I'm going to go back to that in 1 second. Before I do that, we also have documentation. So this is where you can publish documents from JupyterLab. And this gets into the idea of the smart paper. But even without a smart paper, what this allows you to do is to publish markdown files in Jupyter notebooks so that you can share them either publicly or privately, which if I go to the settings tab, you'll see that we have a way of toggling that on and off. So right now, this is a public project. So if I shared the URL of my documentation, anybody would have access to that. But if this was something that it's still in draft, or it's just a private project that I don't want to share with external parties, then I can keep it as private. And the only people that would have access to that would be people in my permission list. So this particular one, I've invited a lot of people to, but everybody here that has access, that has permissions in my project, are then able to access everything within this repo, just like I am able to. With the one difference that this is connected to GitHub, and I can make commits to that GitHub account, but the permissions on the Labs platform are separate from the permissions in GitHub. So what's nice about that is that you don't have to go and invite a bunch of people and get them seats in GitHub just to be able to work with them on a project in the Labs platform. So I've already spun up a server, and just to quickly show you what that looks like. So I had opened it, and this is a full-fledged instance of JupyterLab. You can do everything that you would normally be able to do in JupyterLab. You can do markdown files, do new notebooks, Python code. You can get into the terminal. When it is spun up, it will pre-populate with some packages that like CAD, the latest version of CAD, that are already done for you. But we've intentionally kept that list short for a couple of reasons. One is because we don't want to just pre-install a bunch of packages that makes it take longer for it to spin up. So we try to be lean on what packages that are there. And two, we don't want to choose those packages for you. But what we have done is we have two types of requirements documents that you can create. This one doesn't have it, but I can explain them to you. We have our requirements.txt, which is something that's required for running the code, and it says what packages are there. But we've created another one, another type of requirements file, that if you have it within your project, you can specify other packages that you want, and it will pre-install those once it launches JupyterLab. So you don't have to do that yourself. And it's just another way of making it very easy for your collaborators, if they are to go in, that they don't have to worry about downloading matplotlib or plotly. It's already installed because you specified that you want that installed for this project. We've added some other things, like we added integration with a nice app that does easy commits. So I can go ahead and do my commits here and push them to the repo. We also created our own way of doing publishing. So I showed you one way that's publishing within the platform, but if you just wanted to publish one document and share that, you can also right click and click publish document, which creates a HTML document, a static site that's stored in S3 buckets that can then also be shared and with anybody. You can do it on social media, but it's just a static HTML page. But again, everybody that has access to this project is able to come in here and work on these. Like, for example, this is like the CAD model that I created. So anybody that's able to work would be able to do this. Let me jump back into the slideshow. So that was a quick demo of what you have with the platform. And next, I want to touch on the second service that we have, which is very much focused on the presentation layer, which is what we're calling smart papers. And a smart paper is basically, it's a typical white paper, but it has simulation capabilities embedded in it. And think of it kind of like an interactive exhibit in a museum. If you go to the museum, you can go to the different exhibits, you can read the little placards that tell you what's going on. But a lot of museums have switched to having interactive elements because it really engages better with the people that have come in. And they're going to walk away with a better understanding because it's something tangible. They were able to do something with it. And so we want to take that idea and expand upon that and have your ability to create this multimedia experience that expands on that white paper while still keeping the technical details of those white paper for your users. So this means you could have your white paper embedded with videos, with your notebooks, code snippets, but then you can also have a widget that would allow your user to, within a sandbox environment, be able to select some of the initial conditions of the model, click simulate, and it will show them some results. And so another way to look at this is it's really the combination of a lot of different things. So if you have your white paper that is for a technical audience, you can blend that. People have already blended that with some content that really creates that light paper element. It creates more of like an executive summary of their project. The white paper and the system model, that's really if you're going to share the code of your project to give somebody one level deeper than just the documentation of the math specification and descriptions of the project. And then you may also be creating some tutorials showing how things work, showing how the code works. We really want to take all of that and create one single document within the platform that really addresses all of the different artifacts here, but also allows it for a larger audience beyond just a technical audience. So the applications of this, first off, I mean, white papers are a sales and marketing tool. I mean, that's the primary purpose of them. You put them out there for a technical audience to read them and get a better understanding of what you're doing, and they're going to make a decision if they're going to dive even deeper. They generally go further than that if they want to engage with you, but that's the purpose. It's for a specific audience to pull them in. So could you do that with a larger audience than just the technical audience? And that's what we're hoping with the smart paper. But there's also other ways that you could use this, such as research and journalism. So if you have your academic project and it has a system model that you want to be able to publish and have people play around with, this is a great way of doing it to give people a deeper understanding of your research. And with journalism, there's lots of journalism articles that have diagrams. They may be quoting some data. If that had some interactive element, that could really help share that story at a deeper level with the audience consuming that. And all this leads to a greater verifiability and legitimacy of your project. It's been an interesting year this year in Web3. There's always news stories of scams out there. Wouldn't it be great if when you're looking into a project and you want to see if you want to be involved with that project, getting that deeper dive into it, actually seeing not only that they've written up some white paper, but there's actually an interactive model that you can play with. It really helps in your audience trusting that you've actually put something out there that's legitimate. And then finally, you publish these as a way of getting community involvement. That could be because it's very early stage and you're trying to attract collaborators, people to join your DAO, really just get the word out there. Or it could be a little bit further along in your project. Maybe you're seeking fundraising and you want to, again, show that this is a legitimate project and people should be investing in you. So there's a way of publishing these smart papers that really gets the audience to get involved. So why don't I go back into the platform and show you some examples of this. So we're still in the same project, and I touched on the documentation of it. This was our MVP of it. So with what I just went over with this idea that this is a multimedia document, what we have here is in my overview, it is a combination of markdown and code snippets, but I've taken it a bit further where if you click on the model, this is actually all the code blocks. So you can go in and see exactly how this model works, get an understanding of how many time steps it is, what it's trying to do there, and really helps in showing some legitimacy of this. You can now see the nuts and bolts of this model. But if I needed to, also have some high level view of the project, I've also created this that just gives you a walkthrough of like, what is the project? Why did I do it? What is this dam that I'm talking about in Ethiopia? So there's some images that I put in, some diagrams that I created, actual drawings. So I can really give a lot of high level information that shares for a different audience. If they're not going to understand the technical, they could go through this and get an understanding of, what is this project all about? And then finally, there is the smart paper aspect of it, which gives that interactive model. So in this case, we took several runs of the CAD model, stored that data, and created this sandbox for our audience to play with. And so in this is just a prototype that we created to really give you that idea. But what it does is it lets you select a river. These are all the different rivers that make up the Nile River, and then allows you to select how greedy you want this model to be. So at a high level, what the model's basically doing is it's saying that there's this brand new hydroelectric dam and there's an empty reservoir behind it, and it has a river flowing through. How greedy do you want this dam to be to fill that reservoir? So you get to select the greediness of the percentage. So I could be incredibly greedy, run the simulation, and you'll see, hey, this actually fills up pretty fast because it's hit the upper limit of how much it can hold. But if I want to be really low on my greediness, then you'll see that it takes a lot longer to fill that reservoir. Very basic, but the idea is that this could be expanded upon to really demonstrate much more complicated concepts, with the goal of it being that you're trying to bring in an audience that would not be able just to understand your model looking directly at the code. You want them to be able to play around with the model without having to play with Python and say, okay, now I see what they're trying to do, and maybe I can actually have some usefulness out of this toy model. Another one that we did was Uniswap. And so what we did is BlockScience had actually created a prototype of the Uniswap model, and we wanted to see what we could do with creating a smart paper around that. So you're going to see a lot of familiar elements here. We have, there's pieces of the code. There's an interactive element here that's, borrowed heavily from the other one I showed you. But basically, I can select this. It's going to update this chart, and then there's some other charts down here that updates as well. But this is the same idea where this could be a single widget for several different charts, or we could have had it where this controls this chart, but then you go down to here, and this is a different example, and it has its own thing. So there's many different ways you can do that. Oops. This also has, it shows the abilities. If I click on this, it'll take you to the original white paper. It'll just download it as a PDF. This will take you directly into the GitHub repo. So you're able to do several different linking. It doesn't have to just be all contained within the documentation here. You could really create a page just dedicated to external sources or all your references so that people can go and read all the information that led you to your conclusions of your paper. And again, here you can see this is the actual notebook. So you can see how it works with a couple of the things already run. Another partnership that we have is we are working with Monitar, and we are in the process of creating a smart paper for them as well. Some of you may have seen I did a presentation for the SCRF, which is the Smart Contract Research Foundation. And I did a joint presentation with Andrew Clark, who is the CTO of Monitar. Monitar is an AI auditing firm. They have some clients in insurance and some others, and he wanted to do a presentation on loss functions, and we decided to partner up to say, hey, could we take his research and create something interesting as a smart paper? So this is a work in progress. Our goal is actually to create 2 artifacts out of this. So Monitar has their own blog on their website. So we're going to create a white labeled version of this where they can host it on their blog, but then allow to link in to into a smart paper on our platform that then has the ability for it not to just be one long page, but actually to have a table of contents so that you can have the audience, jump around to the different aspects of the paper. But with this, it goes into what loss functions are, has some equations. What's missing here is that this is just a bunch of random data points that was created for the purpose of the paper. And then what he does is he goes through each of these different measurement types or modeling types and shows you what the results would be. That's the piece that's missing. There's supposed to be a bunch of lines on here as well, which there will be. But this allows you then to step through and then see all the different equations for the different types that you can do, and the final version with some conclusions. So that's an example of what we're trying to develop with the smart papers, and where we're trying to go with that. The final thing that we are experimenting with this is to actually have a version of your model where the user has more flexibility on the parameters that they run, and they can run it, and it's not contained within a sandbox. It's really, they can put in any parameter, run the results, and possibly download the results. So you could share your model and have them be able to run it on the platform, so they can play around with it. Finally, the third thing that we've been focused on is consulting services. And this is where specifically we are partnering up with Token Engineering Labs. And that is to offer help to anybody that wants to be able to produce the kind of designs and release economies based on everything that we've gone over today, but they need a little bit of help in doing that. So in conjunction with them, we're able to offer services that can do your design. We can build models, we can do testing. Our teams have specialists in mathematics and Python modeling, CAD modeling. So if you need an extension of your team, we're here to help you. We can talk. But we also, if you already have a team, we can offer services to upgrade your team with certain skills and do training courses. And this is where I mentioned that I was going to touch on the relationship with BlockScience again. We have a very close partnership with BlockScience. If there are special needs that we need from them, they have there are times when their staff is actually able to add on to our staff to help get projects done if need be, and they have the availability. But we're very closely integrated with them. Our staff has been trained by them. So there's a very tight relationship with them. And what I wanted to do was actually talk about one of our clients that gave us permission to share. So this is Unergy, who, if some of you may know Shebneb, she's involved in the token engineering community. She's just a wonderful person. And she's been very much involved for years on this Unergy project, which has the goal of basically renewable energy, cleaning up the planet, making it so we can all still live here. And specifically for Unergy, what they're trying to do is get funding for additional solar projects to expand upon existing solar projects in the EU. She wants to support regenerative art. So there's an NFT involved that will give you a unique NFT of right now, I think all the art is different types of trees. And she really wants to support other types of regenerative art that is there. And then also give people the ability to offset their own carbon. So directly I took a flight, I have a calculation of how much carbon that created, and I wanna do my part and offset that. And in return, you'll get an NFT with information on exactly what you offset with, which is the two offerings that they have. So the YC tokens is specifically so that people can invest in new solar projects. And so there are several projects that they're involved with, connected with, there's a bunch of solar panels on top of some schools in the EU, along with some other projects. And they already have years worth of data of the energy that's been collected from these solar panels. And that is what they're going to use for then the offsets, which is the second product offering, where you can buy into the carbon credits that they already have, and then offset your own carbon footprint. And you'll get an NFT as a result of that, which actually has all the information specifically in the metadata of what was used to offset your carbon. But they came to us because they had a couple challenges. There was 4 things specifically that they were looking for. So the first was data validation. They're collecting this solar panel energy from a bunch of different sites. Fortunately, they're coming in similar formats. So data formatting is not an issue, but they needed data validation because they were seeing some oddities. There were times when there were gaps. And so what they wanted us to do is to address that for them. They're very concerned about transparency and wanting people to trust what they're doing. So don't just take their word on it that they have these carbon credits to sell. They want to be very transparent in showing this is the carbon credits that we've collected. This is where it came from, and this is what you'll be getting by buying those. So they want to be very transparent on what they're doing. They need a financial model that doesn't involve a token that is in regards to selling those carbon credits. And then finally, they want to offer that YC token that's going to help in fundraising for new solar projects. And it has all the challenges of any sort of token project. So they came to us to get some assistance with that. So specifically how we're helping them is we've created an automated model for them that does data validation and also creates a holistic report so that they can see all the different project sites and how much error was found in each of those. And so it gives recommendations on what to do with that data. And then once they have that verified data, that's going into their carbon credit model, which we're helping them build to really figure out what the pricing should be based on what their goals are, and several different simulations that we can run against that, all of which is within, like I showed you, our documentation hub. So they have that ability to have things private and public. They're working on creating the documentation that they want to share publicly, and it's all being stored in that one place. And they're interested in also, once we have these models done, of doing a smart paper. And then finally, the token design. So it is the whole thing where they have a overview of how they want the economy to work, but they need our help with the specification, the design, the testing, and then of course looking to some other things like the incentive design, governance, and then also lots of testing on risks, making sure that they're not going to allow bad actors to come in and cause problems with the design of the model. So in summary, what we're offering and what I want to talk about today was 3 areas. So we have our platform that's really allowing teams of people to do this kind of work together within one place and make it very easy to share. The presentation layer, the smart papers, which is then allowing you to then publish those externally and have people get a better understanding of what your project is, and giving interactive elements that increase the legitimacy of your project. And then finally, the services for consulting, which allows us to get you to that endpoint if you don't have the resources internally or the skill sets internally to get you to that final goal. So thank you. I think this presentation is going to be shared and a recording shared. So lots of different links here to go through, but that is it for us for BlockScience Labs. Thank you very much, and happy to answer questions.
Thank you very much, Chris. Thank you for this holistic presentation. Yeah, what we saw today is the coverage of the full process from early stage discovery over specification to we skipped a little bit the implementation, but we talked very much about the benefits of proper data visualization and data analytics, and how what the advances are if this is integrated within one process, within one platform, within one service. So thank you very much for to all of you who participated today in the presentations. We did have some questions in the chat, so maybe we should So first of all, a call to action. So for everyone who is still here, please post your questions into the chat. But we do have some of them that are not answered yet. So I see a question from Tiago. What are the main differences between the work involving the token engineering design process for a token ecosystem and the work related with the economist in a central bank, for example? Is it a matter of changing the context of the application, or is it a whole paradigm in the field of complex systems? Who wants to take this question? Chris, Julia, or should I?
Go for it.
Thank you very much. So the main difference between there are many differences. So like in the central bank, there are many divisions and many different specializations. So if you look at how many people work there, you would need to specify further whom you're referring to. But an economist in this context is mostly working on particular types of models and trying to infer from those models information that he or she can use to pass them on to people making policy decisions. And the main difference that I can tell you about from my naive point of view is that the ways of how they model the economy are vastly different to how we model our economies. I mean, the general context is the same. We try to, build economies and model them and understand what will be the impacts on macro variables based on some micro actions or based on some policies or based on some system controls. But the way how we try to understand those systems, this is very different. And in the context of central banks, you very often hear something that is called the DSGE model, so dynamic stochastic general equilibrium models, which means that in this context there are assumed equilibria that in the economy, and those equilibria are shocked by some external exogenous processes. So this is how a system that is stable and is modeled to be stable is then being brought out of stability by this external exogenous shock. And then the investigation is when will the system recover, or how long will it take to do it, or what should be the optimal conditions to bring back the system into equilibrium. Which means that here we have an explicit assumption about the system is being stable and can be brought back into stability by control of the system. What we do in complex systems engineering is much more complicated than this, because we do acknowledge that the systems that we are building are per se not always stable or in equilibrium. So we acknowledge that we have a system that is moving, that is in disequilibrium, that is just unstable to some extent. And we are trying to understand what will be this impact, but not isolating this one only impact and holding all the other things fixed. But we're saying, okay, there is something that is happening, and we want to see what will be the influence of this onto our system. So this is a very, very, very vague and very high level comparison between how I understand the differences between the central bank economist and versus a complex systems engineer. I hope this helps. I don't know what your context here is. But happy to elaborate more on this if you're interested. Do we have anything else?
There's a couple of things there I could jump in on. Then you can.
Sure, Chris, please.
And thank you, Rohan, for answering the question. So yeah, I want to be very clear. This is not closed sourcing CAD/CAD at all on the Labs platform. It's purely just creating other tools that you can use. You do not. You don't have to use CAD/CAD to use our platform, and you don't have to use our platform to use CAD/CAD. So both are not requirements of each other. Definitely not doing that. And then Morella asked about the data validation. It is done off-chain right now. And Unergy has not shared their models yet, but they definitely are going to. That's one of their goals in the transparency of what they're doing. So once that's all done, you will be able to dive in and see what they're doing.
Thank you, Chris. We have two more questions that I see in the chat. Are those examples from a published paper? Yes, they are. I can point you to them if you're interested. Will the slides be made available after the call? Yes, we will make the slides available, but also the recording of the call itself. So all the information will be linked there as well. What else have we got?
I think Rohan has a question.
Let me see. Let me go through it. Rohan.
You might have to type it up, Rohan.
May I unmute? Okay, yeah. Let me see. Zaremba has one question in the meantime. I have many questions. The first one would be, do you see a lot of interest or readiness to hire large multidisciplinary teams for token design rather than have a quick one-person token economy design that's done in 2 weeks? My second main question has to be asked aloud. Okay, so the first question is whether we do see, and we can talk about this, whether we do see a readiness in the space to hire people that would engage with us on long-term projects. And my brief answer before I hand over to you, Chris, yes, people who are serious about proper system design and who want to build sustainable infrastructure, who consider the systems that you're building like as a infrastructure and not like a business case or like a quick business model, they really want to have this modeled and tested and validated and challenged with all of the instruments that we throw at them. And yes, those people are willing and also very interested to bring in an interdisciplinary team of people because they acknowledge that no one person can solve this, but also you need different perspectives to accommodate for all of the differences, difficulties and challenges and different perspectives of the token engineering world. Chris, do you have something to add to this?
Yeah, so what we've seen from the people coming to us is they're coming with the idea of what they want to accomplish. They have a lot of knowledge. They may or may not have somebody that has some specialization in the design on their team, but they may be looking for that expertise, or they're just looking for the modeling expertise. And I think that this community, there's a big need for more people to have that combination of understanding the math, being able to do the modeling, understanding how token economies work, and because they're not finding that, that's sprouting up a lot of people offering services to help them out. So I think getting involved with all the different communities, upgrading these skills. There's definitely a lot of projects still out there that need that talent. So yeah, we're definitely seeing that where they have the designs, they know what they want to do, and they just need that extra little bit to then move forward because they don't have the technical expertise on their team.
Yeah, very true. So people who are experts in their domain and they are very serious about building something that they know very much about, they are looking for our help and expertise to support them with all of the cryptoeconomic, complex systems, engineering, modeling decisions that they don't have the capacity in-house to cover. Yeah, true. Cool. We have two people who wanted to ask a question, but they would want it to be unmuted. So maybe we should do this. Rohan, so I will unmute you now and allow you to ask your question. Please go on.
You're unmuted, but we can't hear you, Rohan.
Let me.
Oh, there you go.
Okay, yeah. Yeah, so I wanted to ask the question to Chris. Like, I've been using the BlockScience Labs platform since like few weeks now, and the one thing that it's been a great platform. Most of my research work, anything I do, I build it out on Notion, and it's very easy for me to export it into a Markdown and just put it into my docs file. So publishing docs have been pretty seamless for me. The one thing I was really stuck on was how to build these interactive widgets with buttons or like sliders. That wasn't immediately obvious to me. I understood that there's some JavaScript widgets or IPython widgets that could do that, but if there's a repo that I can just look at how you've done it before, it would really help. Yeah.
Sure. So like I mentioned, this is something that we're still developing. So this is how we're approaching this, because we feel like this is a new idea that's coming out there based on a lot of great things that have already been done. For example, the Common Stack, a team of people put together that augmented bonding curve, which is a really great tool. And so things like that gave us this idea of, hey, the interactive model is really something that would benefit. So what we're trying to figure out is, how can we create a scalable solution so that you don't need a bunch of web developers to create something like that? So that's something we're still trying to figure out. Right now, we are helping we can do the JavaScript widgets. We're going to be creating documentation that starts to show how it's done. But that's really our end vision. This is still very early in our product development. But that is our ultimate goal. We want anybody to be able to create something like this in a DIY fashion. So to be continued on more documentation, more examples, so that you could do this instead of having to rely on a web developer or for us to do it for you.
Yeah, okay, cool. Thank you very much. I have some more questions before I unmute the next person. So there were two things that I can ask pretty quickly. No, one thing. So do we have any in-depth courses, intense crash course for aspiring token engineers? What could you say about this? Chris, Julia?
I'll start. I can start. I get this question all the time. I think there's a ton of people incredibly excited about this field. And it's also with CAD/CAD, they want to know what resources are available for CAD/CAD. And right now, there's not a lot. There are some things like there's cadcad.edu. You can go through their paid courses. There's the community you can join up with. They have community calls to get some information. I know they're in development. They're soon to be launching the beta version of CAD/CAD 1.0, which is the reference implementation, which is going to be the new version of CAD/CAD that's really retooling the design of how you build CAD/CAD models. And once they have that, then there's going to be documentation. There already is some documentation around that. But my ultimate goal of the Labs platform is to really enhance it with a lot of tutorials and documentation over time. We also have the vision of creating a stock and flow type interface that allows you to build CAD/CAD models, simple prototypes, and then it will create all the code behind the scenes for you for very simple models, so that you can just put in some inputs, have a transition happen, and have outputs, and then start, as we advance it, you can start to string them together in a stock and flow diagram. All of that is further down in the pipeline, but the CAD/CAD reference implementation will make that possible to really be able to create a UI on top of it. So as far as BlockScience Labs is concerned, we don't have a lot of documentation yet for training. I would have to point you to other resources, but that is definitely something that as our platform matures, as we get more features in the platform, we really want to make it not only a collaborative platform, but a learning platform where you can use it to really get a better understanding, create your own models, publish those models, get feedback from others in the community, and just grow from there.
Yeah, thank you. And I don't know if you mentioned this, Chris, but there is the TE Academy, obviously the course for all of the people who want to start with token engineering. There is this fundamentals course that you can take where in 5 modules you would be able to learn the basics of token engineering. Obviously, there is a long way to go from, like starting and understanding the fundamentals to building token models on your own. But I think that the community in general supports all people who want to learn with the formats like this, where you would be, able to learn and talk to people, or just join the communities and interact with them. Everyone is eager to help. We have a question that I don't know if you want to take, Chris, but the question about the pricing of the platform. So if you want to address this now, you can. If not, you can also forward some links or some information after the call.
So lucky for everyone, as of now, for the pricing of the platform, we're really not charging for access to the platform. You'll see when you sign up that it's going to ask for a credit card and all of that. That's more for unlocking access to running simulations if you're going to run on our AWS, because you need, there's a cost associated with that. But as a company, we've really pivoted from a B2C model to a B2B model. So we've really been focusing on the consulting services, but we still have the platform out there and available. So if you want to try it out, you can sign up. You don't have to pay for a subscription right now. I know it's going to tell you have a 14-day trial, but that is something we just decided not to enforce for the time being. So please feel free to use the platform, join our Discord, give us feedback, things you like, things to see. Definitely, we want to have the platform continue to grow to be more useful. And then once we get to a certain state where we feel that there's a tier that is of high value, then that might be eventually behind a paywall. But as of now, the platform's open and free to use.
Cool, thank you. So finally, we have one person who wants to ask a question aloud. So Zaremba, let me just unmute you and feel free to ask a question now.
Hi, thank you. So this is a question, I suppose, to all of you. So this is something I've been thinking about both when I was learning CAD and during the token engineering fundamentals course. But I haven't started using CAD for like very complicated models, so I haven't had the chance to sort of test its boundaries. I'm wondering, how do you think about causality and causal relationships? And that's either in terms of the CAD implementations or in general for designing models. And here I see the problem of common language because I normally think about causality more from the inference point of view rather than from the design point of view. So for example, when I think about causality as statistical causality or intervention-based causality, that would sort of allow different types of structures. So for statistical causality, it would be like asymmetrical dependence, lag-based, potentially multiple lags, and here whether I guess part of the question would also be if you think about the systems as discrete per se or as potentially discretization of continuous state space models. So I guess this is very, very open-ended question. I'm just curious, how do you think about it?
It is, yeah. There are multiple questions here. So, so first of all, in causal relations, causality, and you have. We talked about this, I think, already a few times here in this community when we said that there are two steps in the design of a token system. The first is like the validation, verification of the mechanisms, and then modeling some evolutionary the dynamics of the model. So I would say that in the design process, in the first stage, you have the full control over all of the causalities. So you can design how the system is supposed to update based on the state update mechanisms that you define. So you wouldn't have any problems with having so all of the responsibility would lie on your shoulders. And then when you move over to some assumptions about behaviors of users, then you can make assumptions about them and then get to consequences of those actions manifested through the state update mechanisms. But this is to some extent dependent on what you choose to define in the first place. What I'm trying to say here is that you can be very clear about some parts, and you can cancel out all of the causalities, because you can say, okay, let's just test this one particular mechanism. Let's just test this one state update, and let's just test this one element of your economy. And then when you advance it and when you assemble all of those features into one particular system model that aligns all of the components into one thing, then you would get into you would need to be more careful about which conclusions can you derive from a simulation. So this is this. Regarding the implementation continuous time versus this discrete time. I mean, obviously, you can model dynamical systems in both of those realms, and you can choose whatever you want to do. But it has some benefits of thinking of those systems in discrete time, because the way how they are implemented on chain is, per definition, a discrete system, right? So you would gather all of the state of the possible transactions into one meme pool, and then you would say, based on this, what's happening now, then you get a discrete event that is triggering the state update into the next state of the economy, right? So actually, the CAD modeling framework and the dynamical system specification approach that we are taking is very close to the physical life implementation of the system on chain, which again, is, you can get to different solutions, or you can get to different conclusions from the different modeling types, but you would be very comfortable with having something in discrete time because you would implement it on chain anyways. And this would help you to understand that, okay, this is very close to the real implementation of the system in reality. Yeah, I hope this answers the question. I don't know, I forgot some of the aspects that you've mentioned, but those were the two that I could remember.
It maybe doesn't fully answer it, but it gives me something to think about.
Cool, thank you very much.
What I was after. Say?
Perfect, thank you very much. Anyone wants to add to this answer? Chris, Julia, Julian, maybe any comments from your side?
I don't have anything.
Cool. If this is it, then looking at the chat and looking at the time, I would say that we have exhausted all of the time that we had today, but also we're able to answer most of the questions, or all of the questions that we've seen in the from our community. So this leaves me with concluding the event today, and thanking you so much for your participation. Thanking Julia for her presentation, thanking Chris for his presentation, and obviously thanking everyone who was in the call and contributed with questions and comments to the success of this event. We will update the recording, and we will make sure to distribute all the news around all the services and future events and all of the things that we're doing, because we really appreciate you guys being interested in our community, and hope to serve you with our presentations and events and everything that we do. Thank you very much, and see you next time. Bye-bye.
Thank you.